All right, so welcome to my presentation, Creating Great Documentation with Altium Draftsman. My name is Kelly Wigington. I work for a company, VPI Technology Group in Salt Lake City. Okay, first I want to do just a poll to check our demographics here. How many of you are engineers by show of hands? It's surprising to me, like in the keynote address when he asked for show of hands, a lot of engineers here. I'm a PCB designer, so I'm in that discipline. But now with the, I don't know, I think the interactiveness and the ease of Altium Designer, more and more engineers are like, hey, I want to do that. I don't want to turn it over to the PCB guy. This is too much fun. Okay. Yeah, and then they're like, oh, I can't, okay, my philosophy is you engineers have so much else you have to learn and keep track of and keep updated on that you're like, okay, this is not one more thing I need on my plate. So I hope that you take the opportunity then to turn it over to us PCB designers. Now, how many of you in here are specialist PCB designers? Okay, fewer percentage. And how long have you used Altium Designer? Anybody here 1 year or less using Altium Designer? Great, great. You're coming here to learn. 3 years or more? Good. And now 5 years or more. Boy, Altium Designer's been out and being used for a long time. That's good. All right, so one more poll. How many of you are using Altium Designer 19, latest update? And I noticed I just booted my computer up this morning, launched it, and it said, hey, there's another update available. I appreciate how Altium always keeps updated. You know, it's like if somebody reports a bug, it's just short time later and a new version comes out that takes care of it. How many of you still using Altium Designer 18? Okay. That was a big update there, just to switch the graphical user interface. How many AD17 or earlier?
I just can't test it when I'm 7.
Okay.
Because it's not working.
Okay. Now, I recommend, well, okay, it is quite an adjustment to go from 17 to 18 for the new graphical user interface, but I suggest for the features and the speed and the power that you'll gain doing that to get updated. All right, how many of you in here are currently using Draftsman for your documentation? This is good. So maybe you're hoping to pick up a few new tricks or something, but you're already well familiar with it. Okay, so first, when we start a Draftsman document, we have to start with a title block. There are some standard title blocks provided, as you've seen, or you may have a custom title block that you create that matches your company format, proprietary information and such. Let me just mention now, I've got everything detailed in the slides on how to do the documentation, Gerber drawings, Fab detail, assembly drawings, and I've done it all step by step in the slides. So anything that you see here, you go, oh, you know, I want to remember how to do that. First of all, Altium is going to put the slides online. I noticed last year it took maybe 2 or 3 weeks to do that. If anybody just like, oh, I need this right away, just come up to me afterward, give me your email address, and I'll send you the PDF slides. Because everything you see here you can do just step by step. At least it was designed to do so. I'm not planning to jump back and forth from the program, because that keeps us kind of on schedule and on pace. But at the end, if there's time and I have some questions, I'll do that. So first of all, you want to set up your page options. And, man, my screen is blank, so I'm going to have to rely a little bit on just what I see on the projector here. But in the page options, you want to create what is called a DWS dot document that is the format for the Altium Designer Draftsman template. And then you built into that all of your title block information. Now, you'll want to do your zones in there as well. Oh, let's first talk about the parameters. Add the parameters to your title block template so that everything is formatted there, the size, the font, location, everything that you want. You want to put your parameters in there, of course, with an equal sign so that you can fill them in a tabular format, which we'll see later, rather than having to just enter them on each individual sheet as you might otherwise. All right, now, when you add your own custom parameters, and we're going to talk about there's 4 different kinds of parameters. You can use system, project parameters, such, but if you're doing your own parameters, this is the Windows dialog box that you use to do so. And, oops, I hit the wrong button. Up here, you just put in an equal sign. You first click on this little icon here. That gives you a field where you put in the equal sign. It'll show you the system parameters that are available, project parameters that are already available and built in. You want to avoid using duplicate parameters because that can cause some confusion down the road. So first check and see, like in this case, where we're putting in a revision, check and see if there's already a system parameter revision in there so that you don't duplicate it as a user parameter. So here's where I have outlined the different styles of parameters. If you look in the properties dialog box, you'll see that they each have different icons or prefixes on these that designate them as system parameters. System parameters are fixed and built in there. You cannot edit, remove, delete them. They're just those that need to maintain the system. There are user parameters, which are the ones that you add custom to your own desires and wishes. Project parameters, which we're going to talk about a little bit later. Project parameters are really great because if you've got several Draftsman document files, you've got your assembly drawing, Fab drawing, Gerber drawing, I'll show you how you can enter parameters at the project level so that it globally fills in everything without having to do it either page by page or even document by document. Okay, and then there's some PCB parameters also that are related just to the individual drawing. Now, these would be those unique. So all these would be project parameters for me, all the same dates, drawn by, checked across the board that you can just change at the project level. At the PCB parameter level, then you would want to just change the title independently. For example, assembly drawing, Fab detail, Gerber layers, that kind of thing. So each of these levels of parameters have kind of their own purpose. Yes? Variants, I don't know. I'm not sure that they do. Well, variants are for other purposes, so I don't know that they are available and useful here. And then if you put variants in, do they appear as parameters in Draftsman? Okay. All right, sorry, I can't answer that question for you.
It shows up on schematics.
Well, yeah, I've used variants for those kind of things, but I don't know if it's related to what we're doing here in Draftsman or not. Okay, finally, you want to put your company logo in here, and this is really easy. You just do from the place menu, place graphic, and go find a nice JPEG or a PNG of your company logo, place it in here. You can resize it. Really simple, easy to do, clean, and a nice feature for all of your title blocks. Okay, remember we're still in the template file, not in the actual Draftsman document. So this is just our overlay that's going to be used in our Draftsman documents. Okay, now they have automatic zones built in here, and you'll want to use the zones. You want to set up the zones in your template, because when you import your template into your actual Draftsman document, it's going to override what you've got in there anyway. So if you have, standard format for your sheet, you can put the alpha characters horizontally across the bottom, the numeric numbers across the side vertically. You have those options that you can choose here in this dialog box. But set them up in your template because then they will automatically come into your Draftsman document when you get to that point.
One of the parameters, the ability to reverse that in the order, it looks like they always start from the lower right-hand corner.
Yeah, I believe you can. Yeah, we'll look at that afterward. But yeah, it does give you several options there, and you can change the amount of them, so it's pretty flexible. Okay, after saving the title block, this is saved as a, what is it, a DW? I can't read it there. Okay, thanks. After saving the title block as a primary sheet with your checked by your proprietary information, for your secondary sheets, you typically don't need or want that information on sheets 2, 3, 4, and 5. So then you just go delete that information off of the side here, and then just save only the title block with sheet number and pertinent information as your, I call it the secondary sheet here. So you have two different title block templates that you're going to use to start your Draftsman documents. Okay, so now we use these title block templates to create our fab assembly or other drawings. And we just create a new Draftsman document that gives you some standard options to start with. And the greatest thing about Draftsman is that once you have formatted what you say, ooh, this is my ideal custom fab detail that I like and I want to use it on all my other jobs, then you save that Draftsman document as another template. It's a separate document, as you'll see in your PCB project, and you can just copy those from one project to the next and keep all of your notes, information, and that standard. That's really helpful. Okay, now from the Properties panel, and this is now in our new Draftsman document that we've just created. Now we want to go back and link our template file that we created with the title block, link it in there just like this, and then here is our, we're going to do first a Gerber Layer document. There's our title block in here. We'll go in and I'll show you how to fill in the parameters in a few slides. But first we're going to do kind of our Gerber Layer stack up here. So we just say place and board fabrication view. That's a little bit misleading to me, but anyway, that's how you put in one of your board layers. And then in the next screen, we have, okay, interesting thing about, most of you already dealt with this. When you're in Draftsman, the property format is a little different than we're used to otherwise from the pull-down menus at the top. You control everything from these properties over here on this list, and there's so many different options. You just need to go in and kind of kick the tires and try different things out to see what works for you. here what we've done is we brought it in at a 1-to-1 scale. It didn't fit our sheet very well. We're going to increase the size to 4x scale so that it fits our sheet. And then the next thing we're going to do is, if you like black and white documents, which is pretty typical if you're going to replicate them, you go into the second tab here in your Properties dialog box. Gosh, I'm really shaking today. I guess I must be nervous. And you can go change the color to black or any other shade that you want to. So this is, if we call this our Gerber Draftsman document, then this is showing what our top layer Gerber is going to look like to the fabrication shop. Next thing, we just go in and we want to do a second sheet for our other subsequent layers, and we just click anywhere in the white field around this, and the pop-up context-sensitive dialog box pops up, and we just say add a sheet. So now second sheet appears, and now we have to go back in and say, okay, this, I want to link my secondary title block template to my second sheet and those subsequent. So we go in and just change that in the parameters. It's going to be in the sheet parameters here that you can do that. And now you can go back to the menu and say place another fabrication detail. It's easier to, now that we've already sized it, to just copy the top layer that we placed previously, copy it to the second sheet. It's already the size we want. And then we just go in here in the properties. Notice I've got this selected. From the properties, we can go in and say, okay, now I want to see layer 2 ground. And we just repeat that process for the rest of the Gerber layers in our board, so that anybody who views or prints that out can just see what our stack up looks like from silkscreen, solder paste on down to the bottom silkscreen. So that makes a useful drawing for someone to just inspect all the Gerber layers in a hard copy or a PDF. Okay, that's all there is to that. Oh, now we're going to populate the title block fields. Now, you're maybe familiar with, for the sheet parameters, you just will do those from the properties box that will pop up here on the right. If you want to do them globally for the entire project, all the documents, then you go back to the top menu, project, and project options. This is where we have all these different tabs. You go clear over to the parameters tab over here, and now it'll first present you with a blank screen here. You simply add a parameter, and you need to make sure that these match the same text spelled out exactly as you created them in your template. So if you see, the drawn by and date code down here, they have to correspond with what you add up here. And then once you add those, then you can go ahead, put the values in here, and they will appear on every sheet in every drawing that you have linked to that particular project. Really quick, easy, helpful thing to do. Yes?
You can also take and copy them from a previous project as a block and paste it. Just do a Control-V.
Okay. Now, when you copy those, do you copy them right from here?
From this panel in another project that you've already got.
Uh-huh.
A standard setup. And then you can simply drop them in here.
So are you saying that you can simply multiple select them all? Oh, okay.
Control-A. Grab it as a table.
Okay. Very good. Thanks for sharing that. It's great. We can all learn here. Okay. And as I mentioned, because this one is sheet specific, or not sheet specific, but document specific, we title this Gerber Layer. If we put our title in the project, as I just demonstrated, that title would appear on our fab drawing, our assembly drawing, all those. So that's why we have this one just separately here in our parameters panel for this particular sheet or document. Okay, now let's create a really nice fab drawing in Draftsman. Now, this is the format that I like for my fab drawings that I do, and I'm going to show you how to accomplish that. So first, again, we start out with a blank template, and you can use that place Draftsman document command that I showed earlier. From now on, I just copy, like if I just did my Gerber drawing, I would just copy it, save it as my fab drawing, and then I would delete out all the layers in there, and then just go and create my fab drawing in there. Now you see here that I have gone in and changed the parameter for the document as the fabrication drawing. And now we start out by placing under place additional views the drill drawing view, and that places a replication of our PCB, and it has symbols or characters representative of all the drilled holes we have in the PCB. I'll show you how to manage those later on. Again, I just went in and did this 3x scale so that it would fill the sheet where I wanted it to. Okay, next we want to dimension the drawing, and you have a lot of different dimension options in here. I like the ordinate dimensions where you start at a 0 point and then just work your way up. It's a little cleaner when you have a lot of notches and edges and that to dimension in your drawing. You can also do radial dimensions, all kinds of things. Just go under place, and these are all the dimension options that you have down here. Now, the interesting thing about this that sometimes gets you when you place a dimension is it may say 0 on a couple of them, and then 1, 2, and you go, wait a minute, you know, I need some resolution here. So by default, it just puts it in with no numbers behind the 0. And so then you need to go in and here in this menu, go in and change it to a precision of 2 or 3 decimal points, depending on if you're dimensioning in inches or millimeters. You can also do dual dimensions, inches and millimeters, and set the precision independently for each one of those. But it really gives you a nice detailed dimension drawing.
You can also reset your preferences. You can go to preferences for this particular menu and reset it all there.
Thank you. Yes. Go to your preferences under Draftsman, and you can go set all the default preferences you want for those, and then that saves you the trouble of having to go mess with all these every time you create a new dimension drawing. Thanks for that. Okay, now we want to add our preferred Fav Notes here, and this is pretty easy. You can copy and paste your favorite notes in there. The one thing that's kind of unusual and interesting about this is that you need to paste them in line by line down here. You can't edit them up here in the text box. You have to add them kind of bullet point by bullet point down here in this dialog box. But it does space them nicely for you, gives them numbers. You can add in like circles or triangles on over your numbers so you can reference other details and things if you want to. But just copy your standard notes in there and you're off and running. Okay, now here is the layer stack table. Place, layer stack legend. This is the default way that it comes in, and as I pointed out, again, you see a lot of zeros in here, and you're like, wait, what's with my thickness? That's just because the default doesn't contain any decimal precision on that. So once you place it, you can go into the properties for that and you can set a lot of different options. Go in and set your precision. Also for the different views, you can set it to a compact view, which instead of a big tall sandwich, it kind of compresses it down. It automatically spreads these lines out here with all of your descriptions for the layers. And then you see here in this view, I went in and I changed the precision so that now we can see the actual thickness of the layers, and I did it in the dual units just so you could see how that feature works. Down here at the bottom, it extracts this information from the PCB. I think I kind of skipped over that in a previous slide, but at the top menu, there's simply an update from PCB, and it goes and extracts the information from the PCB and fills it into your Draftsman document. So all this information from the layer stack up comes from your PCB document. If you use the layer stack manager to add the desired dielectric thicknesses, copper, weight, and all that stuff in here, it's going to just bring that right in here for you, and it'll also give you the total thickness. Now, I'm going to mention kind of a risky thing you can do here. You can override these in the Draftsman document. In fact, if for some reason you don't like the layer name, you can go into, I think it's on my next slide, yeah, in this, from this link here, you can go in and look at your layer stack up. You can edit any of these values in here, even the thicknesses. And you can even go in and put in your own value, custom value for the total thickness. Now, this is useful in the fact that if I have a 4-layer board and there's no impedance control, I don't care what the vendor uses for the material and the thicknesses. I just leave that column out, but I do want it to say that I want a 62 mil thick board. So then I can just go in here, type that in, and override everything else. So I just want to caution you, the risk there is if you copy this Draftsman document over to your next project and you import your information from there, and now it is critical and important, anything that you override and type in here is still going to be maintained. So be aware of that so that it doesn't come back and bite you later on. Let's see, is there anything else I want to cover here? Go on. Okay, so now you can create some custom columns in here, which I do for impedance. Now, I've noticed that Altium recently, I think it was version 19, added some additional impedance charting features. I kind of got used to doing my impedances right here in the layer stack table. I just went in, created my own custom column heading, and I typed in some information into these. Here in this case, I did, this is at 90 ohm impedance. I don't know what the next one says, sorry. But then for each layer, I can go in and put, okay, my trace width for these, trace and space. Put my trace width in at 6.5 mils and 4 mil spacing. That tells the fab shop that these are my 90 ohm impedance controlled traces and that they need to be maintained properly. So that's kind of a cool add-on that you can do. You can customize it in a lot of ways, so it's really useful. Okay, now we place the drill table back to the place menu, and drill table, it's going to come in looking something like this. You can do a lot of customization here from the panel, the properties panel. You can go in, and you probably noticed in the previous slide that again, well, it would come in without any decimal precision accuracy. So here, oh, I got my slides going the wrong way, I think. Okay, here's where it came in with, all my holes are 0. Again, that is just the precision that needs to be set up in this properties menu. give it dual precision. You can also do mils and millimeters if you choose. The hole tolerance, you cannot type that in here. It doesn't even let you override it in here. That is extracted from the PCB, and in your pad properties for the PCB, you have to set up the hole tolerance if you do want to show that in your drill drawing. What I do is I go into the PCB, I select a via, and then right-click to select similar items. It selects all my vias, assuming they're all the same size. Then with them selected, I go into the properties dialog box there and say, okay, for my 12 mil vias, I want a tolerance of +2, -12, which essentially tells the shop, you can plate them shut if you want, it doesn't matter to me. Then I select all my pads and give them a ±3 mil tolerance. I go back, if I have any mounting holes, my philosophy is if they're under 100 mils, I'm going to do a 3 mil tolerance, plus or minus. If they're over 100 mil drill, then I'm going to give it a ±5 mil accuracy there. So I just individually select the mounting holes, and I go in and for all those, change them to ±5 mils. Sorry, I don't have a slide of how I do that in the PCB, but it is in the properties dialog box for pads and vias. Okay, now the options that you have for your drill chart or table here is you can go in, click on this link, it'll bring up this dialog box. You can go in and group by these different options here. You might need to just experiment with a couple of different things till you see the sorting and the order and the columns that you want. And then it will, by default, come in with a lot of crazy symbols in here. Symbols are useful. I prefer to use alpha characters, so I go in and select them by size and then change this for the symbol from just, a star or whatever to an A. That way, if the fab shop calls and says, hey, we've got a problem with this particular drill, they can reference it by a alpha symbol, an alpha character, rather than saying this crazy octagon-shaped star-looking thing. So that's my philosophy there.
I have a quick question.
Yeah.
So I may be misremembering this, please correct me if I'm wrong. When I place a drill table into Draftsman and it auto-generates symbols for it, I've noticed, at least on mine, I believe, that when I place another drill table in the PCB space itself, it auto-generates a different set of symbols. I know you can manually change those symbols. Is there a quick easy way to make sure those symbols are in sync?
Not that I'm aware. Is there anything in preferences that let you do that? I haven't found any other way. Now, are you?
I have an issue with that because I have the drill table for the drill drawings, like in the Gerbers, and whenever I pass those documents over, sometimes my engineers have complained that, the Draftsman drill table symbols aren't matching up here. And I don't think that's an issue, but
Yeah. Yes.
Lots of problems. I also use the drill pairs. The drill pairs also tends to help sync the database of drill table versus the Draftsman drill table better by doing the drill layer pairs.
Right. Yeah, there has been occasion where, like you, I've done separate drill tables, and it has been some effort to keep them in sync that way. So that would be something good to submit to Bug Crunch for Altium in future versions.
I've also had problems with the round off, where some of my designers like to use mils, and some of them like to use millimeters, and that ends up with that minute .0001 out there somewhere that you can't see. And so I've had to go in and find similar, select all my vias manually.
Yep, I feel your pain there. So yeah, that's something that could be enhanced in Altium Designer. Okay, so now we have this great looking fab drawing, and I'm quickly running out of time, so we're gonna go over to the assembly drawing. This assembly drawing is great. I love it because like many of you, we've had to go use a mechanical drawing to do a duplicate silkscreen outline for all of our components with an embedded reference designator in the middle so that when we create our assembly drawing, we can have all the designators appear at the centroid of those components. Now, with Draftsman, you no longer need to do that mechanical layer for your outlines. It uses, well, you can use a couple of different things. I'll show you here in the next slides. Again, we're just going to update our parameter here to say assembly drawing. I've just copied the fab drawing, called it the assembly drawing document, and then we're going to just update our assembly information here. So now we do place, board assembly view. It comes in just like this. Mostly it'll look pretty good. Some situations that we're going to look at here, there will be some problems that we need to take care of. I increase it to a 3x scale so that it appears large on the sheet. Now, how many of you like to use 3D models with all of your components in the PCB? I want to see a lot of hands go up. You know, when that first came out, it was like, okay, this is kind of cool. It's a lot of extra work, and it's just sort of, you know, a glitzy thing. But now I am a firm believer in adding those models because besides just looking really cool, it allows you to do a lot of clearance checking. It allows you to do modeling in SolidWorks. And same token here, Draftsman uses those out by default. It uses those outlines in your 3D model to create the assembly drawing. And they look great, don't they? So that's another reason to use 3D models in all of your components when you create them. But for the discrete resistors and capacitors, it kind of obscures some of the text designators inside there. Is that my alarm that I need to quit? Okay, heard somebody's text message. Okay, now, in this case, we have a designator on the LED that's sitting on top of some of the other lines. And so this is something that I didn't learn for a long time. I picked it up from somebody else that saying, man, I wish you could move the designators individually. Of course, you can move them down here in the parameters, different inside or outside the component outline. But he goes, oh, just hold down the control key as you drag the reference designator and piece of cake. So that was really sweet how you can individually customize those. Now, the nice thing is you can use this link here to globally go into a tabular data format, like to change all your resistors, all your capacitors at once into a different outline. Again, for those, the 3D model outlines don't work out too well. Now, the important thing is from up here in this option dialog box, by default, it'll be BOM, which doesn't really do you any good for this, what you want to do. You want to change these all by footprints. So you select footprints. Now it shows you, it sorts all of your components by footprint. Then you can go in individually for each footprint type and change the geometry source, which from the bounding box, well, let's see, by default it'll be the 3D model. You can change it to a bounding box, which gives you a bigger outline around your capacitors and resistors. From there, you can go to this next tab down here at the bottom, from geometry to the parameters, and then you can find the ideal text size for all of your 0402 resistors, maybe another font size for all of your 0603, and when you're finished with that, you end up with some really nice looking assembly information here for all of your components. The fiducials, you can go in. If you check this box at the bottom there, it's outlined. It says apply for all similar. And that means for all fiducials, we can just go in, click the eyeball, turn them or uncheck them, turn them off. We don't need to have fiducials visible on our assembly drawing anyway. Now from there, you can go in, like I just copy this. It's already scaled for this, but then I just go in and you can change the view so that gives you a side view. You can do a ISO perspective view. And again, I'm going to go through this pretty rapidly, but if you just get the PDF slides, you can do all this stuff step by step on your own. As I mentioned, it now added this realistic view for the top and bottom side of your board. Now I do that as part of my assembly drawing, and customers really like that. But there's so many options. I just challenge you to go in and on a free Friday afternoon, when you don't have anything left to do the rest of the day. Well, that doesn't ever happen, does it? Okay, just tell your boss you got to hijack some of your time to go in and play around with some of the features. Just go in and try those things. Now, really quickly, once you have created these Draftsman files, the best thing is, I hope you've already experienced the beauty of the out job containers, because, you can go in and you can link your Draftsman documents now to your out job file so that with the click of a button, you can immediately generate the PDF for your assembly drawing, your fab drawing, any of those. So your documentation is a snap. That is the end of my presentation. My quote is, you can do amazing things with Altium Designer if you learn how to use it effectively. Besides doing PCB layout, I do a lot of custom coaching. So if you ever saying, how the heck did he do that? You can give me a call, come up and get one of my business cards, and I can talk you through it. I appreciate your time and wish you the best the rest of the afternoon.